Okay, today we're starting on extra difficult, extra challenging. It says extra crazy, but they're not really that difficult. We're kind of like increasing the complexity. These are more complex linear combinations. So we started off yesterday with some pretty straightforward ones. Okay, so we started off yesterday with these, where the first one, the zero pair like jumped out at you. Okay, like if there was a positive and negative, it was obvious where your opposites were. The second one we did, we had to multiply the entire row by negative to create a zero pair. So we had two numbers, but they weren't opposites, so we flipped the signs on everything to make them opposite. Okay? Then we did this word problem in class yesterday with the coins, and for this one, we had to multiply one of our rows by something to create a zero pair. So here we didn't have a zero pair. But it was easy to make one. We just had to multiply one row by something, okay? So that's what we did yesterday. So now we're looking at some kind of more challenging ones. We're probably, once again, going to do this word problem in class together. What I would like you to do, though, is I would like you to define the variables and write your equations, because I want to see how you do on that. So part of your homework tonight with this video is I want you to define your variables and write equations for these. Again, I would encourage you not to use X and Y, but you do you. I would use like V for vanilla and C for chocolate, but that's what I would do. Okay, so I want you to do that. And we're going to do those together in class, but I want to go through these. So for these problems, this is kind of like what we had on this this quarter and nickel question, okay? So for this one, I don't see a zero pair. Nothing jumps out at me. Now, believe it or not, there are 4 different ways I could get a zero pair for this. I could multiply the top row by -1, and then that would make, well, no, I couldn't do that. No, I couldn't do that. There's 4 different things. I could multiply by -2, I could multiply by -3, I could multiply by -7, or, yeah, there's 3 ways. So there's a lot of different ways I could get this. I'm going to go with the easiest way. So I see right here I have y and 3y. I am really close to being able to get a zero pair right there. All I need is for this to become -3y. To do that, I have to scale up my entire row by -3. -3 times -7 is +21, and those are x's. Okay. And again, what I'm noticing is that you guys are forgetting, you're not multiplying to everything. So if you do the arrows as you multiply, that's going to hopefully help you keep from making that mistake. Remember, we stop when we hit parentheses, so make sure you put the entire equation in parentheses. -3 times y is -3y. We obviously don't multiply by the equal sign. -3 times -19, I don't know what that is. So like I said in class, I better hear nothing but clickety-clack, clickety-clack. Y'all need to start using these calculators. I mean, like, you have one. I know this wasn't the calculator you were thinking. You were thinking of the one like on your phone, but this is the calculator you get, so let's use it. -3 times -19, because I'm distributing that -3 to the -19, gives me +57. Okay. Now at this point, I'm combining these 2 equations. Okay. -2 and +21. Remember, we're doing -2 and +21 gives me 19. So I have 19 x's. 3 and -3y zeroes these out. So I have no y's, so I don't need to write anything down. My equal sign comes down because I didn't do anything to it. And then I have -19 and 57. Gives me +38. Now, at this point, you could put this in your calculator. You could put this in y1 and this in y2 and look for the row where they're the same. But again, this is a 6th grade equation. You should be able to do this one. I have 19 x's. I want 1 x. So I divide by 19. If I do it on one side, I got to do it to the other side. If I do it to one thing, I got to do it to everything. The 19's cancel away, leaving me an x. And remember, I'm dividing, so 38 divided by 19 is 2. Okay? Remember, you should be using your calculator, even for arithmetic. Why? Because we like to get the right answer. Okay. Now, interestingly enough, this is the step that people seem to be having the most trouble with. So I'm going to take it a little bit slower. Okay, I'm going to go to one of these equations. So remember, first we eliminate one variable, and this is the same thing for all systems. We eliminate one variable, so we do what we got to do to make it. We make a zero pair. We find or make a zero pair. We eliminate one of the variables, and we solve for the first one. So we found x. Now we're going to use the variable we found to find the other one. So we're going to use x to figure out what y is. So I'm going to look at the first equation. You could use the second one. It's the same thing. -7x plus y equals -19. Okay. Now that I've done this, I know what x is. X is worth 2. So I'm going to replace. When we substitute, we're replacing with that value. So the x isn't there anymore. I saw a lot of people on a recent test that we took where they would say 7x2. No, the x is gone. I replaced the x with 2. Now again, you could put this in y1 and that in y2, but this is not difficult. So if you want to put it in y1 and y2, you go nuts, but I'm going to solve it by hand. Negative 7 times 2 is negative 14, plus y equals negative 19. To get rid of the negative 14, I'm going to add 14 to both sides. And I get, that zeroes away. We get y equals negative 5. Okay, now if I want to check this, I can. I'll tell you I've already checked it, but if I want to check it, I could say, well, I know what x, I think x is 2 and I think y is negative 5. So I would go to the other equation. So negative 2 times x, which is 2, plus 3 times y, which is negative 5, should equal negative 19. If I put that in my calculator, negative 2 times 2 plus 3 times negative 5 gives me negative 19, which is what I'm looking for. Okay, so I write this as an ordered pair. There was a question yesterday, well, what happens if it's a word problem? What ordered pair do you write? If it's a word problem, you give me a word answer. Okay, so if they're asking about, you know, like chickens and cows, you don't say chickens, comma, cows. You say there are 5 chickens and 8 cows, or whatever the answer is. Okay, so that's the first one. This one is, you know, a little bit more complicated. Now, this is the most complicated thing that you're going to see. I have no letters. Now, you see there's a 2x and a negative 2y, but they're not the same letter. They're not a zero pair. 2x and 2y cannot cancel each other out. They have to be the same letter to be a zero pair. All right. Actually, I just want to really quick jump back to this one. I noticed this right here. You see how they're both equal to negative 19? So then the question becomes, well, if they both equal negative 19, don't they both equal the same thing? No, I can't do it that way. This is not a setting equal. If it's ever in standard form, I have to do it like this. So I can explain to you why later, but this is the method that we're going to use for this, because we still have extra variables. The point is, even if I did set them equal, I would say I would end up with x's and y's, and it didn't help me. Okay. The point is, I'm trying to get rid of a variable, not make more variables. Okay. So I'm sorry, go back to this one. Okay, so we have 2x plus 3y equals negative 1, 5x minus 2y equals negative 12. I don't have the same letter anywhere. And I can't just multiply one row. Now, I could multiply this row by 2.5, but like, isn't that just, I don't want decimals, like, I don't want that, okay? So in this case, I'm going to have to multiply both rows by something to make a zero pair, okay? Now, I could multiply the top row by negative 5. That would give me, that would make this negative, this would be negative 10. Bottom row by positive 5, positive 2, that would give me, okay, so let's see what my options are. I can multiply, so I'm going to have to multiply both rows is what I'm trying to get at. I can multiply this row. If I multiply this by negative 5 and this by positive 2, that'll give me 10 and negative 10 as a zero pair. I could do this by positive 5 and that by negative 2, and I would get negative 10. I could do this by negative 2, this by 2, and that by 3. That looks easiest because, see, they're already opposite sign. All I got to do is make them the same number. This is a little weird, but again, what I'm doing is I'm trying to create a zero pair. Let me show you what that looks like. Okay, so I'm going to multiply the top row by 2 and the bottom row by 3. And the reason I'm doing that is because I'm trying to make a zero pair out of this. So let's see what happens when I do that. 2 times 2 is 4x. 2 times 3 is positive 6y. 2 times negative 1 is negative 2. So far, so good? All right, now, 3 times 5 is, now this is the second row, is 15x. 3 times negative 2 is minus 6y. 3 times negative 12 is negative 36. Do you see how now we've created a zero pair? Now this just takes some kind of looking to do. Again, I could have done times 5 up here and negative 2 down here. All I'm trying to do is create a zero pair. All right? And now that I've created a zero, okay, seriously? Sorry, hold on a second. My lights just went off. And we're back. The lights are on now. Okay, so now that I have this zero pair here, I can zero it out. So my 6 and my negative 6 zero away, and I start combining. 4 and 15 is 19x. That zeroed away. My equal sign comes straight down, and negative 2 and negative 36 is negative 38. Okay, again, you could put this in the calculator if you want to, but you don't have to. I divide by 19 because I'm trying to get 1x. I get x equals negative 38 divided by 19 is negative 2. Now that I know what x is, I'm going to use it to find y. I'm going to go to the first equation because it's the first one I see. 2 times x, which is negative 2, plus 3y equals negative 1. Again, if you want to put the left side in y1 and the right side in y2, you can. 2 times negative 2 is negative 4, plus 3y equals negative 1. Now I'm going to add 4 to both sides to get the y by itself. Again, if you're using the calculator, you probably already got this and you're like, why are you taking so much time? Divide everything by 3 and I get y equals 1. Okay? So now my answer is negative 2, 1. Again, I can check this in the first equation. I think that x is negative 2, so 5 times negative 2 minus 2, I think that y is 1. Should equal negative 12. Well, let's see what I get. 5 times negative 2 minus 2 times 1. I get negative 12, so I'm right, and I write my ordered pair. Negative 2, 1. We're going to practice this in class tomorrow. If you have any questions or want to be in a small group, just let me know.